Good morning and welcome to the Overview Podcast. My name is Tagg. I'm a PhD student here at Stanford, and I'm joined this morning by a very special guest, Professor Juan Alonso, who currently serves as the Department Chair of Aeronautics and Astronautics here at Stanford. And Professor Alonso, when we were preparing for this interview this morning, we were reading through some of your background and your bio, and we found a very interesting anecdote. We read that you were part of the team at MIT that holds the record for the speed record over water for human-powered vehicles. And we thought that was just like really cool, and we had never heard about that, and we figured we don't talk about that enough. So what was that? Can you tell us about that?
Sure. Well, first of all, thanks for having me.
Yeah, of course.
Very nice of you guys to do these podcasts, and I'm happy to sort of provide any thoughts and suggestions that may be helpful. I was an undergrad at MIT, but I arrived there about 6 months before Daedalus, which was the human-powered airplane that still holds the world record speed and distance, was flown. So I was not able to go to Greece to actually see that and to help with it, but I did help building parts. And then when the Daedalus team came back, a team of students who had participated in Daedalus and Professor Mark Drella, who was the advisor, were looking for other projects to do in human power. And there were only two competitions left. One was a human-powered helicopter, and the second one was a human-powered vehicle over water. The human-powered helicopter required a gym that was much larger than what MIT had at the time, so we crossed that one off the list, and the only thing that was left was
over water.
A $25,000 prize for the first team to break 20 knots of speed over water on human power alone. So a friend of mine who was an undergrad that had been in the Daedalus project was kind of the lead of the project. His name was Mark Schaefer. And he recruited about 10 people or so, and we all worked for, I don't know how many hours and how many years, but through most of our undergraduate career to try to put together that vehicle that eventually got 18 and a half knots.
So which is how many miles per hour for those of us who aren't most familiar with knots?
Well, it's a little bit more.
A little more than 20 miles per hour.
It's faster than an 8-man cruise shell with Olympic class athletes.
Oh, okay. So
by
we're
a significant amount.
moving here.
So it's really cruising over water. But because we got to 18 and a half, the rule of the competition was also that it was the first team to break 20 knots or the team to hold the world record at the end of 1992.
And is that currently the world record
It's
still?
still the world record.
Wow.
The vehicle is in the lobby of the Boston Museum of Science.
Wow.
If you want to see it. And we did get $25,000, but divided among about 15 people who participated.
I mean, you still got more than $1,000 there.
Well,
I would rather have the world record than the cash
prize. I have to
prize,
tell you,
so.
when you look at 3 years of work and the hours that we sank into that, it really was
not the greatest hourly wage for that.
Lower than minimum wage for sure, but it was a great experience, and it's a fun thing to sort of tell my child.
Yeah, that's the best opening anecdote we could have ever hoped for. Isaac and I were chatting before this. We're like, what can we do during our graduate degree here? We need to go break some record, like can we go do the most loops around the Golden Gate Bridge, or like what world record is out there, that we can go do, because we want something like that on our resume.
So I would tell you that it was mostly initiative from the student side.
Okay.
Faculty member that was willing to help, and an office called MIT Sea Grant who gave us $5,000 to buy carbon fiber.
All right.
So you can do it here too.
All right. Well, you hear that, Isaac?
No excuses.
We're going to be breaking some world records this year.
I like it.
Well, speaking of MIT, I want to ask you about your experience there, because you had an interesting path to when you got there. You started out your undergraduate career in Spain, right?
Yeah.
And then you were a transfer student that came to MIT. And I want to ask about that because I feel like a lot of students are kind of wondering, not just, like how do I get into a school like MIT? But you had an especially interesting way of doing it, where you were a transfer from an international transfer. I wanted to ask how that kind of worked and how you made yourself an enticing applicant to come over to MIT from Spain.
Mind you, this was the late 80s, and it was a very different world, no internet, so very little information available, particularly abroad, about the U.S. educational system. So when I applied to college in Spain, I was following the standard path of I finish high school, I do the national exam, I get accepted to a university inside Spain, and I just go there. I had a good friend who was also a Boy Scout, who was 2 years older than me and was Canadian. And he went to MIT. And I remember after I had applied and gotten into college, and as I was starting college in Spain, my home country, this guy said to me, you got to come to try to apply to MIT. This is a great place. I'm like, sure. So I went to visit him in Christmas time, and he gave me a tour. I sent in an application, and I got in. So I didn't have much more of a plan than to say, okay, I'm going to go to this place for 1 year. If I like it, I'll stay. if I don't like it, I'll come back to Spain and just finish my studies in my home country
you
and my home
staying
city.
at MIT, right?
That was 1988, so what is it, about 37 years or so? So
Don't need to put any age on if we don't need to. But,
Yeah.
So that's so interesting because I want to ask more about like when you came to MIT, was anything different, or what do you feel like, what skills kind of helped you then succeed at MIT if coming over from Spain?
I think the educational system in Spain, as it is in France and Italy, Germany, even the UK, is a bit more rigorous in the mathematics and the physics and the chemistry than the US at the high school level. So it prepares you very well for college. But the college experience in Spain and these other countries is completely different, the undergraduate college experience, than here in the US. So significantly larger numbers of students, much less interaction with faculty or labs, the impossibility of doing something like what I did here as an undergraduate in a human biohydrofoil, those things just, at the time at least, didn't happen. Hopefully it's improved substantially. But I think I was very well prepared with the strong skills to be able to understand anything.
You're talking like the mathematical skills and like the academic background.
I mean, I will tell you, you probably never heard of the school I went to in Madrid for 1 year.
Probably not.
But I can guarantee you that 60 to 70% of the students in that place would have gotten straight A's and B's at MIT. So there's a lot of talent around the world, and some happen to come here to some elite institutions like Stanford as well. And that's lovely because a number of opportunities are afforded to these students that allow them to progress further, I would say, in their professional career. But the talent is ubiquitous. So, yeah.
What about at MIT? I mean, you said that you had a good preparation for like the academic background, the mathematics.
Yeah.
Then what extracurriculars did you get into MIT besides like outside the classroom? I mean, you obviously were part of that team that broke the record of the over water, but what else did you do to
MIT, like here, we have something called REU. There they have something called Europe, the Undergraduate Research Opportunities Program. So I work in labs over the summer.
With MIT professors?
Yes, I work with Ed Crowley in his space systems lab, looking at laser interferometry for measurements of systems. I work in the ocean engineering design lab, learning about CAD and high fidelity geometry shapes. A number of other activities like that. I also played in the squash team at MIT.
Oh, cool.
So I think that was a really important thing for my career too, because it sort of drops you off in a place where you have a whole bunch of immediate friends that are doing things like you are, and at the same time it forces you to be very focused with your studies because you're doing 2-3 hours of practice every day. So, and then you have games over the weekend and stuff like that. So I think all those activities do shape you into the person that you actually are, and I think, U.S. top institutions have the ability to have the laboratories, the resources, that place that gave us $5,000 to buy carbon fiber. That was $5,000 a while back, and it was just 2 undergrads walking in to talk to somebody and say, hey, we need some money to build this crazy thing.
That's so awesome.
And that they would actually believe that you can do and actually have the resources.
Maybe being next to MIT, they get weird requests like that all the time as students walk in.
Well, this was part of the MIT Sea grant, so it was an internal sort of funding resource, but Stanford has similar things. And the fact that the environment is set up so the student can have all these different experiences, if they have the initiative to do it themselves. Nobody comes over and says, hey, here's $10,000 that you can do something, right? But all those diverse set of experiences are really important. And in fact, I think I learned as much from some of those experiences as I learned from my classroom work, whether it's technical or it's about communication or discipline or focus or not getting tired of something and not giving up. All those things come not just from somebody lecturing to you in the classroom. So
they came by going out and doing something,
Absolutely.
a variety of real-world experiences, getting your hands dirty.
And learning from other students. I mean, this student that I tell you that led this project is an amazing engineer. And we try once, we try twice, and it doesn't work, and most of us give up, and this guy would never give up, and you pay attention, and you say, oh, okay,
that's the kind
you got to try 3 or 4 times, and then finally you get it, right? And it actually works, but the first few times it never works.
Yeah, so it sounds like it was a lot of extracurricular activities, like a broad array of experiences that gave you hands-on experience outside the classroom that didn't just take the mathematics or the concepts you were learning, but you went and applied them and you learned some more engineering skills that weren't just
and I would say for a young kid from Madrid, Spain, it opens up your mind.
Yep.
you come out of high school thinking you know what you want to do with your life, and you have no idea. You go to undergraduate, and you still have no idea. But if you have these experiences that expose you to what the best in the world can do, you have like a measuring stick of, it's like the bar is this high if you want to be at the top of your profession.
Yeah.
And you see all these examples of what people do, and it's just inspiring, right? And if you're the person who can thrive in those environments, it's just a unique opportunity. So I am very grateful that whatever I did in my application, they actually accepted me as a transfer student, as a sophomore, and I would definitely do it all over again. It was very impactful in the career path that I followed. So.
I get what you're saying about that. Like when I first came to Stanford, I feel like I saw that bar set higher than I'd seen it before, with some of the amazing students we have here in the faculty, like people that are world class. It raised my sights for what I could accomplish.
Right.
And being around people who I felt like were smarter than me, more accomplished, and had done so many things that I was like, wow, I didn't even think a career could accomplish something like that.
Exactly.
At times gave me a little bit of like fear, like, oh, can I be that good? But also it raised my sights that, hey, I can do more than I think I can.
We all have our personal backgrounds. I came from a very normal working class background, so nobody could tell you that you could put together a spacecraft that's going to fly in a zero-G aircraft, and then it's going to go to the International Space Station. But then you see it there, and you're like, okay, and that's what I need to do. So work hard and solve the right problems. Yeah.
That's awesome.
We'll get back to that later on.
Yes, we will.
Yeah.
So then moving on from MIT, you went and did your graduate degree at Princeton. What was, what was the shift there? What made you want to go towards graduate school? And did you think about going into industry at all, like working, or were you like, did you know that you wanted to go do a master's and PhD in the academic route?
So I did not know that I wanted to do a PhD, but I knew I wanted to design airplanes for a living.
Okay.
And in Spain, where I came from, my plan was to go back to Spain after I finished my studies here in the US. In Spain, where I came from, engineering at the time was actually 6 years. So the engineer's degree, as it was called, it was the equivalent of a master's here. Okay. So I knew I had to go to grad school for a master's, right? And then at least the 6 years of schooling I would have here will be, given some level of accreditation that will allow me to actually work as a working engineer in Spain. But I went to grad school with that thought in mind, and I was involved in research from the beginning. And my advisor at Princeton University was Professor Anthony Jameson, who also came to Stanford when I
was going to say, I recognize that name.
So Tony was one of the best people in the world doing computational fluid dynamics for aircraft design. Yeah. And I just got very excited about what I was doing, and one thing leads to another, and I thought, okay, with a year and a half of a master's, I'm going to do pretty well in terms of understanding the fundamentals, but there are all these new things that the best people in the world at this are actually doing that are going to be necessary to design the aircraft of the future. Why don't I stick around a little bit more? I felt I was still learning a lot, et cetera, so I went on to a PhD.
So it was motivated a lot by then to want to learn.
Yeah.
That you felt there was so much that you could learn before you went into the workforce, and just want to keep sticking around with people that were learning.
I knew that to design different airplanes, you have to develop different methods. Yeah. And I knew that those different methods by then were not being designed in industry yet, so they were being designed in academia. So I wanted to be part of designing the new methods so I could. Then my idea was to finish my PhD and actually work in industry designing airplanes. So that's been a constant in my life, and I've never quite gotten to it, but
you've always been wanting to design airplanes. It's been the goal has been.
So I was interviewing for jobs, and I had job offers from maybe I shouldn't say, but some airplane companies to actually be in their conceptual design groups.
And this was at the end of your PhD?
At the end of it, towards the end of PhD, in addition to interviewing for like management consulting things, which I'm glad I didn't sort of pursue.
You hear that, listeners? No management consulting.
They were offering about 3 times the salary.
I was going to say that was probably a very tempting offer.
But let it be a lesson. I decided, okay, I can always do this other thing first, and if I don't like it, I'll interview back for these companies, but I cannot go there and then sort of go back to the aerospace industry, and it worked out. So. But yeah, it's I was interviewing for all kinds of industry jobs in order to try to go design airplanes when I saw an ad here.
And I want to ask you that because I listened to your other podcast with Dr. Neil Ashton, and you told him something that like you said here, you weren't planning on being a professor. That wasn't your plan all along to like, oh, I want to get my PhD and then I know I want to go be a professor. You were looking to go and design airplanes. You want to go in the industry.
Yeah.
How did you end up here at Stanford of all places, which is obviously a very a very high position? How did you end up here if that wasn't your plan all along?
So part of it is It was exciting in terms of a field of research to do multidisciplinary analysis of optimization, which is starting. I had put myself in a position in grad school to invest significant amount of time and effort and work with the best people in the world for these new emerging agile methodologies, et cetera, et cetera. So my skills were very marketable for industry as somebody bringing in new methods to design airplanes, but they were also very attractive to academia. And when the ad came up, I put in an application, I came and interviewed, and I got a job offer. So I figure, okay, let's do that first. If I don't like the academic life, I can always go back to teaching, to designing airplanes. But I also thought that the path would be harder to go to industry and then 3 years later try to come back to academia. It is possible, and we have positions like professors of the practice, et cetera, but that typically implies a long career in industry and then a transition to academia. So.
That's interesting. It seems like both when you applied to MIT and then you came here to Stanford as professor, two very prestigious positions that it was more like you were well prepared, and then you took advantage of an opportunity when it came up, and you were a solid applicant, and you kind of took advantage of what opportunities came your way.
I've never been one to be shy about jumping onto an opportunity if I think or I have a gut feeling that it's actually going to pay off. I don't mind taking risks. So yeah, many of the decisions I made throughout my life, you'd argue, had a significant level of risk. And leaving Spain when you're 18, sort of starting an academic career when you thought you wanted to design airplanes. But going to NASA headquarters, starting a company, things like this are things that you do because you feel that there's value in them and because you're passionate about it, but also because you are thinking that there's something there and it's worth taking the risk, and it's worked out. So
yeah,
and there have been many decisions too that haven't worked out. So I think we
don't need to talk about those today, right?
No, I mean we don't have to talk about them, but I think people need to know that in order to have one good idea, you have to have 10 bad ideas first. And
do you have one of those in mind? I guess actually, I personally would actually like to hear, because I know we were going to talk about you going to NASA headquarters and you started a company.
No, we've pursued lots of research ideas that, okay, you learn a little bit, but it doesn't necessarily pay off, right? And I think in your generation of Instagram and earlier Facebook, I guess you guys don't know what that is anymore, but you know what I'm trying to say. Everybody just puts out there everything that is perfect and it worked right the first time. And it's not true. Sometimes it works right the third time, but most of the times it worked correctly
but you don't see that on social media. It's always the highlights rather than the lowlights that got you there.
That is terrible, I have to say. I think it's okay to say that, most things that are worthwhile take a lot of effort and hard work, and you don't always get it right the first time, so you have to persevere. And you also, if you like podcasts, which I imagine you do.
I do, yeah.
I love to listen to the Free Economic podcast. You also need to know when to quit. A lot of people talk about grit, and you just, do it and do it and do it until there's something that I remember listening in Free Economics, and I don't know if I'm doing marketing for one of your competing podcasts.
Oh, no, go ahead. Yeah.
But they have, I'm joking, but they have one called The Upside of Quitting. There's an opportunity cost to continue to do something that is just not worthwhile. So you have to know when to pursue something, and you have to know when to stop pursuing something.
You say that happened many times throughout your career with different research ideas that you had
Yes, exactly. Research is about finding new solutions to existing and new problems, and gosh, if we all got it right the first time, it's like if we were so clairvoyant that we know the problem, we know the solution, we tell a graduate student like, hey, just try these couple of things and you're done. PhDs wouldn't take 5 to 6 years, and we will be much more successful as a society than we are today. So, but it takes hard work and lots of tries.
Yeah. Well, what about when you went to NASA headquarters? Can you tell me about that process and kind of how that added to your career and what pushed you in that direction? Because that seems like you were at Stanford. Like, was that something you did concurrent with your professorship at Stanford? Did you leave, or how did that kind of fit into your career journey?
So I had been here for 10 years, and I had just gotten tenure, I think, maybe a year or two before. This was really serendipitous. A new NASA administrator had come in, and with a new NASA administrator, associate administrators for the main mission directorates come up. So a woman by the name of Lisa Porter had been chosen as associate administrator for aeronautics. And I didn't know her very well, but she had been our program manager for a DARPA program that we have had for a couple of years, and she has seen probably what we did for work and my ability to lead a team and something like this, and she called to ask if I will be interested in leading the aeronautics research programs. And at that point, there were all kinds of opinions. So I asked my colleagues here, should I do this? Should I not? Some people would tell me, why go there if you're not going to be able to do anything? Some people were saying, yeah, it's a great opportunity. And my gut instinct told me that, first of all, I love NASA. And I thought it's just such a wonderful institution that does such amazing things for the world that I would love to contribute if I can, if I'm asked. Secondly, I thought, we could bring in a slightly different perspective for the research that the agency was doing, and I thought that could be refreshing, together teamed up with lots of people who had been at NASA for much, much longer than I had, and I thought, why not? Let's go. And it was a good situation for me because I knew I had a position here at Stanford. I was on effectively what's called Interpersonnel Program Act, IPA, so I was on loan to I could actually speak my mind at NASA headquarters and just say what I thought needed to be done, because if they fire me, I could come back to a job I love. So I had 3 years at NASA headquarters on leave from Stanford, and I thought it was a great experience that broadened my scope of aeronautics and astronautics. I had my limited view of the world. That got me to appreciate the difficulties of taking academic research to the next step, and then eventually to industry and to technology readiness levels that are higher. And I just met a large number of very dedicated, amazingly talented, wonderful people that they're friends today. And hopefully I helped a little bit, but you never know. There are big institutions that actually do have a lot of inertia, but I think NASA continues to do amazing work in aeronautics and in space, and I was happy to be a part of it, and I thought it was a very positive experience for me. So.
That's awesome, and I mean, not only did you go to NASA and come back at Stanford, you've also recently started a company as well. Yep. How have these kind of diverse experiences beyond your professorship kind of helped shape you into the mentor, advisor, entrepreneur in today? Has it all kind of been a cohesive thing, or do you feel like it's kind of been
these are new things. You learn every day, right? So I think, I mean, since this is mostly for students, you have to be willing to learn until the day you die, I hope so. And you have to learn new things. You have to be flexible. So I guess in terms of entrepreneurship, I've been working in this domain that the company that we founded eventually sort of has been working on. So it's not like I was a newbie and trying to come up with a new idea to sort of,
this was your career's work, you've been working
Yes, I've been working on it for 20, 25 years. And and I had some pretty clear ideas of what we can do in academia, when we're doing research-oriented type projects, and we're working with grad students who are being trained rather than having done this 4 times. I also had a sort of view of convergence of technologies that I thought needed to be leveraged for the field of simulation and design by simulation. So I had become convinced. I tried it via, university research. I had tried it via open source. I had tried it in various different ways. I became convinced that giving it a crack with venture capital and putting together a team of the best people in the world that are highly experienced was the way to actually make change relatively quickly. And I was, as you get older, your remaining time is finite. So you get a little bit more impatient to get things done more quickly, and I thought this was a good idea.
And I'm guessing quite a different experience from when you were at NASA or at Stanford. I guess NASA is definitely not, it's not an entrepreneurial type of thing. It's government, and then here it's academia. How was it different in the entrepreneurial world? I mean, you say you probably moved faster.
I would say there are different worlds, but NASA has a lot of people who are doing amazing things and have incredibly, forward-thinking ideas. Of course, NASA has a job to be between industry and academia. So they're typically going to take ideas that are out there in a germinal stage and sort of mature them to the point where they're attractive to industry. But they come up with a lot of interesting and very entrepreneurial things. And in fact, many things get spun off, right?
It's interesting for me to learn about all the products we take for granted in everyday lives actually came from NASA research.
But yes, it is a government institution, and it has a lot more restrictions on what they can and cannot do and how quickly they can do it. So venture capital and sort of building a team from scratch was what I thought was needed in this domain at the moment. And fortunately, we were able to convince some people to give us some funds to actually hire a team. We got some really amazing people inspired to sort of contribute to this type of vision. And it's been almost 5 years since we started that company, and the stuff that's been accomplished is really quite remarkable. Right?
I'll say, as someone who is myself learning CFD right now
Yep.
as a graduate student, it's
Yeah.
learning about your company is really cool, and it's cool to see the talent you guys are attracting and the vision you have for your company. I've watched some of your videos about your company and what you guys are doing with CFD and cloud computing. It's really cool stuff, and honestly, it kind of gets me excited about that entrepreneurial spirit, because it's cool that you guys can kind of go fast and do some of these these things where you put all these pieces together, because you have such a highly trained team. It's
as
cool
we
to see.
always say, just like I was saying, you don't always get it right the first time.
Yep.
So you iterate and you do. You have the ability to do it in what they call stealth. So nobody knows what you're working on. So you can try and fail as many times as you want, and you can do it very quickly. Well, maybe not as many as you want, but as many as you need, I should say. And then, yes, that's how the magic happens. And I think Stanford is a really unique place, not just Aeroastro, but other departments, where students who have the skills, who know how high the bar is, because they're working with some of the best people in the world, and who have that itch to actually do something other than writing papers. And I'm not putting down writing papers as my profession, but I have to say that there's a unique combination of student interest, skill that happens here that doesn't happen in many other places. And so this is a very unique place in that sense, that allows both faculty but also graduate students. A number of graduate students who graduated from my lab ended up working, and other labs here in the department and in other departments, computer science, electrical engineering, ended up working in our company. So
that's cool.
So yeah.
So let's talk more about about that students here, not just Stanford, but students in undergrad and graduate school in general. I'm interested to hear some of your advice, because you talked about some things that make a good student, make a good worker at your company. What things would you advise students work on that, say, are either in their undergrad looking to make themselves enticing to a graduate program or into the industry? What skills and what things do you think students can focus on to help their applications and just their development as an engineer?
Yeah. So let me start by saying that advice is cheap. Anybody can give it, and you can take something that resonates with you or not. But I think in general, often you should seek advice from multiple people and see what makes sense, because of your own personal situation, what you want to pursue. So, in terms of getting into grad schools or getting into jobs, I guess, or you're also talking about getting into undergraduate.
Well, maybe we can first talk about getting into, say, an undergraduate graduate program, because you're someone who goes over, you're part of the application process.
So
what things do you look for those who are applicants?
I was going to say, undergraduate programs at most universities in the US are being handled by a central sort of office, like here at Stanford.
It's not up to the department chair of Aeronautics and Astronautics.
And in fact, we have zero visibility into it.
Okay.
But many of us have children who have wanted to get into some of these universities. So obviously you have to have strong records in terms of grades and SATs and everything else. Yeah. You have to be an interesting person in terms of having extracurricular activities that are not just resume building that everybody sees through right away, but actually things that you are interested in or were interested in learning at one point in time, and you invest a significant effort. I've also sort of come to realize that admissions offices are looking for interesting people. So, when everybody has got the perfect GPA and everybody's got the perfect resume and everything else as an undergraduate, some of the essays that you're asked to write are actually scrutinized quite heavily. And I think, particularly for engineers, being a good writer, being a good communicator, being somebody who can just clearly show that what they're passionate about is something that's going to make the world better or the institution better through those essays is actually really important. So do all of the above, but don't get caught in the rat race. Of, oh my God, my life is over if I don't get into Stanford undergraduate. It's not. The one thing we're very fortunate about in the US is that we have, let's say, 30 to 50 institutions that are world class. Not 3, not 2, not 1. 30 to 50 institutions where you're going to receive an incredible undergraduate education, and then you have opportunities to go to graduate schools in various different, top 10 universities or something like this. So if you are a good high school student, if you work hard, if you're an interesting person, you're going to get into one of these top 30 schools in the country. And I would say, because I've seen it with my daughter, I would say to undergraduates, please do not think that getting into one of these 4 or 5 universities around the country is the end all be all. There's probably even better undergraduate educations in many other places, and you will be just fine, and you will do amazing things, and you'll go on to industry, to academia, to whatever, with a very, very successful and fulfilling career. So that's for undergraduate. Of course, once you are lucky enough to get into one of these top 5, 10 places in the country for undergraduate, you have a responsibility to take advantage of the opportunity you've been given. It's a crapshoot, that admission process. Even the admissions offices will tell you that, okay, of the 100%, we can tell the top 50%, but we have to admit the top 5% of us.
So
right?
some factors are down to luck and out of your
It
control.
is absolutely luck, the way you've written things, and various other things, right? There are a lot more, I tell you, in Spain. I mean, compared to MIT, I can tell you that more than half of the students in that school you've never heard of will actually be fabulous engineers with, A averages at MIT. But going back, once you've given that opportunity or being given that opportunity, you have a responsibility to make proper use of those resources. So you have to participate in the educational process. You have to enrich the institution so you leave it a better place for the people who come after you. You have to take the initiative to do various different things, because in life nobody hands anything to you. And you have to make the most out of that opportunity that you've given, whether it's luck or skill or a combination of both. I'm not going to go into that, but I would say, in general, chill. It's just really not the end of the world if you don't get into one of the top 2 or 3 institutions in the country. In fact, you'll be just fine. You'll do amazing things with your life. So
that is comforting to hear. I didn't go to a top 10 institution in my undergrad, but I got lucky, didn't have to come here to Stanford for my graduate degree. But I've seen a lot of other students who don't go to say like, oh, a prestigious institution that do amazing things. We see some of the people
100%.
I look up to that have accomplished the most in academia and industry. They're not always, they didn't always go to MIT or Stanford. Sometimes they're at colleges you haven't heard of or small ones. Like
right, and they're the best engineers in the world. And conversely, there are people who go to top institutions as undergraduates, and they eventually they don't take advantage of it, and they don't accomplish as much. And I think being hungry about doing things is really important at any level, undergraduate, graduate, careers in industry and academia, et cetera, et cetera. So if you care about improving things and doing things differently, you will do amazing things regardless of where you went. So
is that kind of what you look for then when because you're more the part of the process for graduate students, right? Do you look for those who have maybe taken advantage of the chances they've been given, who show that they're an interesting person, that they can write and communicate? Are those things we just talked about? Is that similar to what you look for in a graduate student?
Definitely. I mean, when we look for graduate students that are going to do a PhD, we're looking for somebody who's likely to be a good researcher. And the process is, I was going to say flawed. It's not flawed. It's imperfect. You have a certain amount of information on which you're making decisions, and it's as Professor Kokendeffer will say, it's only partially observable, and you don't know it with full certainty. So you're making some decisions that don't have perfect information. But what do we look for? We look for special people. We look for people who are natively curious. You cannot do something amazing at the level of top of the world, essentially, if you're not deeply curious about something, if you are not willing to put in the time to really understand that curiosity you have that sparks an idea, why is it that way, what we could do about it, et cetera, et cetera. So you look at people who have determination, that are curious, that are entrepreneurial, but not necessarily in the sense of starting companies, but that they're willing to try, risk takers, people who are trying to try something and fail, and then try it again and again until they actually get it, So sometimes all of those things are colored by your own experience, but you're looking for people like that, and those people tend to be very interesting people. They tend to have different interests, and then they come together. In my particular field, if you want to do aircraft design, it's really, and by the way, our department here at Stanford specializes in this, in looking at things at the system level and bringing different technologies to actually make together to make a change. And I think you really want people who've been exposed to a lot of things. You know, there's a very famous book called Range that talks about that the people who come up with some of the best ideas are not necessarily the ones that follow the traditional career path where they got very deep into something and then eventually saw something else. Sometimes you have people who've jumped around from various different areas, and then they go deep and bring all those experiences together in order to do some amazing things. So we look for people, I look for people with about all those types of things. There's an admissions committee, as you know. Each department runs the graduate admissions committee. It's made out of faculty. They all have a slightly different opinion, so you should interview others to see what they tell you that they're looking for. But I would say most of them will have some common elements with what I've said. So,
Yeah.
Ability to do research is important. So, you know, if you've had the opportunity to do some things during undergraduate, at least to be exposed to it and to make a small contribution to a larger project, that's always looked up with, I would say, some significant interest.
I'm guessing you get a lot of applicants that have that perfect GPA and have, you know, the grades and the...
Yeah, unfortunately, obviously that's kind of like a necessary but not sufficient condition, because most people that apply with a large number of applications and the small number of people we accept will have some really good grades, et cetera, et cetera. So try for that, but I would say don't make grades the destination. I mean, the destination is learning, and the capability to always continue to learn. So it is important that you stand out in some way. I have to say that we talk about curiosity and, you know, grit and skills and blah, blah, blah. You know, most admissions to PhD programs these days at top institutions are going to have a Zoom interview. And it's like a 20-minute interview. So how you come across, how you present yourself, how do you talk about the things that you're interested in, how you give a rationale for, you know, what is it that you would like to pursue here at Stanford? Why Stanford? You know, making sure you've done your research. And many of those soft skills are really important as well. You know, the big engineering problems are not going to be solved by a single person. So, you know, opportunities to show that you had teamwork, that you've worked with others, that you sometimes have leadership skills, sometimes you've been a participant in the project. All those things are really important, and they come across in sort of one-on-one personal interviews. There's a reason why the quals used to be oral exams and require a research presentation now, because it is a situation in which, you know, you can see a person more holistically than just through a paper application.
So again, like you said, that beyond the engineering, the communication, the personable skills, the vision, and the ability to share that and work with others.
100%. I mean, if you're going to be successful in life, you have to be good at what you do, but you have to be able to convince others that what you want to do is what you actually need to do. So selling your ideas, you know, inspiring others to follow you, inspiring others to buy into your thoughts and ideas, and wanting to spend as much time as you're going to want to spend in solving that particular problem. These are incredibly useful skills that are just as important as some of the other skills that we have. You know?
Well, I feel like I want to ask like so many questions about the niche at the time. I want to move on to talk a little bit about your vision for the future of both the department and aerospace engineering as it comes to students, because, I mean, students get into these programs, you know, they follow advice to build their skills. I would also like to share with them a little bit about what you feel like is your vision for, maybe we start with the department. Where do you see the department going? What do you hope to achieve as the department chair in the next few years, and what changes do you see coming?
Yeah, so for a department like ours, the vision is, at a high level, is very simple, right? We have to get the best people here in the world. So that means faculty, students, and staff, right? We have to do the best work in the world. It's going to sound like motherhood and apple pie, but it is true, right? Because each of those elements, you know, our recruiting for faculty, our admissions for students, you know, our selection of staff is critical. You know, doing best research in the world, that means we have to have the best people with the best ideas, but then we have to follow through. And that means resources and laboratories and computational facilities and test flight facilities and various other things, and collaborations with other places, you know, whether it's industry, other academic institutions, et cetera, et cetera. So best people, best work or best research, and best education. You know, we're an educational institution. We're also a research institution, but our reason for existence is to take students like you and give you the opportunities that we can give you, all the opportunities we can give you, so you step up and take them to make the best out of your professional career. So the future of any department at Stanford and a top institution is going to be looking at those three pillars. Now, we're an aerospace engineering place, so you could argue, okay, the best people, where do you find them, right? And how do you find them? The best work, how do you choose the areas you're going to be working? And, I would say the ability to sort of carry that, how do you put together a plan that's executable in some sense? So the job of a chair of a department is to sort of worry about that set of things in the strategic sense, to make sure that we're always in an upslope. So, I was a Boy Scout, and I take very seriously leaving any place I go to better than when I found it. I think that's the same thing. We have to continue to improve our department, right? And that requires some strategic thinking. So let's put aside the hiring. We could talk about that, but it's probably less interesting to your I guess, readers or
student audience.
It is important that a department has some sort of sense of direction as to what it wants to pursue. And it's not like a 2-year direction, it's not a 50-year direction, but it's something on the order of 10 to 15 years of problems that are, industrially and societally relevant for our faculty to be pursuing. Now, mind you, we don't tell any faculty member what they need to pursue, but we choose amazing people that sort of think about what are the key things. So when you look at aerospace engineering over the next 15 years, and I'm working with this I'm working on this with some faculty here in terms of, sort of revamping the strategic plan for our department.
Yeah.
What are the key things that emerge in the horizon that are going to be significant problems where fundamental research will have an impact, given the timelines of fundamental research, anywhere between 5, 15 plus years, maybe sometimes longer, right?
Yeah.
So to me, there are 3 or 4 areas. So there's 3 areas and a cross-cutting area. So in aerospace engineering, sustainability of the aerospace enterprise is just fundamental. And that means both aircraft, so commercial transportation, zero emissions, making sure we can continue to grow the air transportation system as the world industrializes and people have, actual or additional money to spend traveling to see their parents, their friends, someplace in the world that they want to go to. This is happening in lots of places that before did not have the resources. So without any restrictions, air transportation will grow at 3 to 5% per year across the world. So that's a very large growth, but it's going to be limited by sustainability concerns. So we have to solve that problem. But space sustainability is also an issue, right? I mean, everybody knows about the difficulties that we're now talking about, the sort of orbital debris, various other things, et cetera, et cetera. So how do we also reuse spacecraft or refurbish spacecraft in orbit? All those things are important. So I think the sustainability of the of the aerospace enterprise is critical. So I would say that's one of the pillars that our department has to play and be sort of playing and be one of the leading sort of departments in the world. The second one is space. So obviously we have an Aeronautics and Astronautics department. So space means lots of things, from space exploration and planetary exploration, but Earth observation, constellations of satellites that actually perform different tasks, and all of the research and the disciplines that go into doing that. So there's also access and reentry from space, right? So if I lump it all in space, I would say that's the second major pillar. And of course it has elements of autonomy and many different things, materials, aerothermodynamics, combustion, all the interesting things that actually happen. But again, all of them with significant improvements on what we can do today and societal impact, right? I would say the third pillar in aerospace is the idea we've always been the leaders in autonomy. And you'd argue recently, last 10 years, sort of autonomous cars and many companies sort of doing software and hardware for autonomy are beginning to take the lead in some specific areas with lots of academic ideas. So we have to understand how in autonomy and robotics we are, and with not just scripted and sort of reactive type situations, but really planning and various other things. We think that robotics is going to play a huge role, and that autonomy of aerospace systems is going to be fundamental. So it's no surprise that a relatively young undergraduate program that we started in the department about 7 years ago or so is the only department in the country that has a requirement for undergraduates on autonomy, not just linear system feedback control.
I didn't know that.
Right?
That's interesting.
So that's because many of us in the faculty feel that this is where things are going. Airplanes have been able to land in cells for 30 years. We're going to be able to sort of do many more things, not just with airplanes, but with other things. And then I would say the idea of AI, ML, and new methods and how they apply to aerospace is kind of a cross-cutting discipline that could have an impact on many of these areas. We have to pay attention to it without the hype. So.
Yeah. Well, I appreciate you sharing the vision with us. I feel like that was a very concrete. You gave us the 3 pillars where you feel like the department is going, and I feel like that should help our students understand. That gives me a better vision of where my research can fit in. I feel like if our undergraduates are listening who are interested in a graduate career,
I'd love to hear that.
Yeah, I feel like that's going to be very helpful. And we're about out of time here, but I appreciate your thoughts on the future and sharing your journey with us. Like, I kind of wish we had another hour just to keep going, but we'll get kicked out of this room here in a little bit. But I really appreciate you taking the time and sharing advice.
My pleasure. Thank you for doing this, and thanks for inviting me. And I look forward to chatting many more times.
All right. Thank you,
All
Professor.
right. Thank you. All right. Thanks very much, guys.